In this video, we are going to learn how to complete the square. So what is completing the square? The goal of using the method of completing the square is to edit a quadratic trinomial so that it is written as a perfect square trinomial. Well, what is a perfect square trinomial? A perfect square trinomial is a quadratic which has two identical factors. So let's look at an example of one of those. So this quadratic, x squared plus 8x plus 16, is a perfect square trinomial because when we factor it, those two factors are identical. So notice here that we have used the x chart in order to factor this, and the two factors that we would get are x plus 4 and x plus 4. Since those factors are identical, we can rewrite it as x plus 4 squared. Now we can do that because anytime you have something times itself, for example, if we have x times x, we can write that as x squared. The same thing were to occur if we had something like x squared times x squared. That is x squared squared. Anytime you have something times itself, you can write it as that value squared. Just one more example. If we have AB times AB, that is AB squared because it's something times itself. So since we can do that with x plus 4 times x plus 4, that means that this quadratic is a perfect square trinomial because it's written as a perfect square. It is an item squared. All right, let's look at some more examples of perfect square trinomials. The first example, x squared plus 10x plus 25, is a perfect square because when we factor it using the x chart, we would be looking for two numbers that multiply to 25 and add to be 10. So those two numbers would be 5 and 5. So when we write our factors as x plus 5 times x plus 5, since they are identical, we can write x plus 5 squared. That is what makes x squared plus 10x plus 25 a perfect square trinomial. In the second example, notice that the signs are a little different here. We have a minus 16x in the middle, and that's perfectly okay. When you factor this, we're looking for two numbers that multiply to be 64 and add to be negative 16. Well, that would be negative 8 and negative 8. So our factors are x minus 8 and x minus 8. Since they are identical, we can write x minus 8 squared. Since we have an item squared, that makes this trinomial a perfect square trinomial. Now let's see if you could figure out the missing c value. So for each of these, they're already in standard form, ax squared plus bx plus c. But I want to see if you can figure out what's the missing number. So when we were to factor these, we're looking for what number would we get when we multiply if those two numbers add to be 2. So what are two numbers that add together that are the exact same that add to be 2? So what number plus itself gives us 2? That would be positive 1, because 1 plus 1 is 2. Now 1 times 1 is 1. So to make this a perfect square trinomial, we would add 1 to both sides. So our factors would be x plus 1 and x plus 1. To write that as a perfect square, that would be x plus 1 squared. So this trinomial, we made it a perfect square because we chose the number that goes right here that would make it a perfect square. All right, let's do example 4. Once again, we want to make this a perfect square. So when we factor, if we were to factor this, we're looking for two numbers that multiply to be something, but we have a stipulation. When we add these two numbers together, they have to be 12, but we want to make sure that those two numbers are identical. So what number plus itself would give you 12? Well, that would be 6, because 6 plus 6 is 12. Now, to find out the number that makes this a perfect square, we would do 6 times 6 to fill in that C value. So 6 times 6 is 36. And now we have a perfect square trinomial. We made it a perfect square because we chose what number goes in for C. Now, if we were to factor this, which we've already kind of done that, our factors would be x plus 6 and x plus 6. Then we can write x plus 6 squared. Okay, now let's take this one step further. We can turn any quadratic into a perfect square trinomial doing what we just did. Okay, we're choosing which number to make C. Now, before we can choose that number that we want for C, we have to have ax squared plus bx equals a C value. So when you have it in standard form, that's great, but what we're going to do is we're actually going to move our C value to the other side of the equation, because right now, this is not a perfect square trinomial, okay? This trinomial right here is not a perfect square, because if I were to factor this, so a number that multiplies to be negative 9 and adds to be 8, all right, so if I were looking for my factors here, two numbers that multiply to be negative 9 and add to be positive 8 would be negative 9 and 1, because negative 9, or sorry, 9 and negative 1, excuse me. So here we go again. All right, negative 9, positive 8. Our two numbers that we're looking for, they would have to be 9 and negative 1, because 9 minus 1 is 8. 9 times negative 1 is negative 9. Okay, well, since these numbers are not identical, this is not a perfect square, which is okay. We've dealt with these types of problems before, but our goal here is to complete the square. So we want to make this be a perfect square. So to do that, we're going to have to add the 9 on both sides. So move it over, move it away from the ax squared plus bx. Now when we do that, it cancels over here. Then we have x squared plus 8x equals 9, okay? So that's our step one. Now what we're doing is we're saying we want to add a number over here so that it becomes a perfect square. All right, so that number that we're going to add, that's essentially what we just did a few minutes ago. I want to add a number so that it multiplies to be something and adds to be 8, but I need those two numbers to be identical. So what are two numbers that are identical that add to be 8? 4 and 4. All right, so 4 times 4 is 16. So I'm going to be adding 16 to both sides. There is a shortcut method to this. There's a formula that will get you that number 16. It'll get you the correct number every single time. And that is to add b divided by 2 squared to both sides, and I'll show you how we do that. So x squared plus 8x plus what number? And then we're going to do the same thing on the other side. We're going to have to add that number on each side, just because anytime you do something to one side of the equation, you have to do it to the other. So the number that's going to go in those blanks is 16, and we found that out by just figuring that out in our heads using what we know about factoring. So to make this a perfect square, every single time, a little shortcut method is to take b and divide it by 2 and square it. So our b is 8, divide that by 2 and square it. That's what we're adding to both sides, and that is equal to 16. Okay, so when we simplify that, you'll see what we come up with is 16. All right, so 8 divided by 2 is 4. 4 squared is 16. Okay, so now what we've done is we took this original quadratic, moved the 9 over, and then we made a perfect square. So now what we can do is continue solving this quadratic using what we already know about solving quadratics. All right, so if we were to factor this, which we made this a perfect square on purpose. We made it a perfect square so that it would be easy to solve. So if we were to factor this, which we already know what we're gonna have, but just to continue this process so you can see it, our two numbers that multiply to be 16 and add to be 8 are 4 and 4. So our factors are x plus 4 times x plus 4 equals, and then we can simplify, 9 plus 16 is 25. All right, so this is x plus 4 squared equals 25. Now we already know how to solve this, and we're going to solve this one by just using square roots. So I'm going to take the square root of each side. All right, and that's going to give me x plus 4 equals, now the square root of 25 is either positive 5 or negative 5, so plus or minus 5. And this is where I'm going to get my two answers. All right, so what this tells me is that I have two equations. I have x plus 4 equals positive 5. That's one answer. Or x plus 4 equals negative 5. Now just continuing to solve, I would subtract 4 on each side here. So x equals 1. Subtract 4 over here. So I would get x equals negative 9. And those are our two answers. So we used the process of completing the square in order to solve this quadratic. The process of completing the square technically stopped right here. We were done at that point. We had completed the square. Okay, here's just another example that we can do together. So we want to solve this by completing the square. So first, to complete the square, we have to have standard form, and then we want to move the c value to the other side. So we're going to add 7 to move it to the other side. And that would leave us with x squared minus 6x equals 7. Okay, now our next step is to find that number that's going to make this left-hand side a perfect square. So what we're going to do is we are going to fill in our new c value by taking negative 6 divided by 2 squared. And then we're going to add that on the other side as well. All right, and at this point we can just simplify, and then the next step is just to solve by the methods that we already know how to use. So we've got x squared minus 6x. Now, negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So I'm actually going to keep that orange so that we can see. Right, and then 7 plus, we just found out that was equal to 9. Okay, and now we can just continue to solve using what we already know. So if we were to factor this, which we don't necessarily have to, but you can, we know that two numbers that multiply to be 9 and add to be negative 6 would be negative 3 and negative 3, and they're identical just as they should be. So that's going to be x minus 3 times x minus 3 equals 16. And that gives us x minus 3 squared equals 16. And then we solve by using square roots. So to solve with square roots, we're just going to take the square root on each side. That gives us x minus 3 equals, the square root of 16 is either positive 4 or negative 4. And this is where our two answers come from. X minus 3 equals 4, and x minus 3 equals negative 4. Okay, so add 3 on each side here, and we get x equals 7. Add 3 here, we get x equals negative 1. All right, one more, just to drive it home. Okay, this one is kind of all scrambled up. It's not in standard form yet, so we need to rearrange it first. So we're going to do x squared. We need to bring this negative 14x over here, so we'd have to add 14x on both sides. Plus 45 equals 0. All right, now we can move the c value over. Okay, so that gives us x squared plus 14x equals negative 45. And now we want to make this a, now we want to make this a perfect square by adding b over 2 squared to both sides. Okay, so b over 2 squared, let's see what that would give us. So 14 over 2 squared. All right, 14 over 2 is 7, and 7 squared is 49. So just to show you that simplified, that's x squared plus 14x plus 49 equals negative 45 plus 49. Right, now we can use the x chart and find what our factors would be. Okay, so what are two numbers that multiply to be 49 and add to be 14? That would be 7, positive 7, so that's going to give us x plus 7 times itself. So I'm going to skip a step here and go ahead and jump to x plus 7 squared equals negative 45 plus 49 is positive 4. Now we're going to solve by taking the square root on each side. All right, so let's see what that gives us. I'm going to come up here, save a little room. So we have x plus 7 equals positive 4 or negative, not 4, 2. The square root of 4 is positive or negative 2. So now to solve this, we've got our two solutions are going to be x plus 7 equals positive 2, x plus 7 equals negative 2, and I'm running out of space. Let's move these over. X plus 7 equals negative 2. All right, so just subtract 7 on both sides. So x equals negative 5. Subtract 7 on both sides, x equals negative 9. So those are our two solutions for this quadratic. So again, the process of completing the square actually stops right here because this is our perfect square trinomial, but then everything after that was just continuing so that we could solve the quadratic.